Hello, this is Susan Poss, and this is a question that one of my students sent to me. As you can see, it's got a lot of fractions in it, and the instructions are to solve. So I'm putting in my dotted line to separate left side from right side. I can think of a couple of ways to work this. I may actually work it twice. So first time I'm going to use the distribution process. I'm going to distribute this fraction over each set of parentheses. And when I do that, I hope you remember how to do fractions. If you don't, you can type them in your calculator. But when I did the negative 2/3 times the positive 1/9, there was nothing to cancel. So I just multiplied straight, whoops, I didn't write that down right. I multiplied straight across the top and straight across the bottom to get that negative 2 over 27. All right, now I'm noticing right here that this 6 over 3 could be simplified down to the whole number 2. And again, here's another technique that's coming to my mind to work this with. I think I will go with the LCD for this equation, and the LCD is 27, lowest common denominator. And then what I did, if you've watched any of the previous videos, I sort of spread this out and put it in a bracket. Each term in a bracket, because I'm preparing to multiply each of these terms by that LCD. And this process is called clearing out or clearing fractions. The reason you choose the LCD is because each of these denominators will cancel into that, and that will eliminate the denominators. They'll all turn into ones. Of course, there's no cancellation on that last one, so I'll just be multiplying across the top. All right, so as I start back across here, this is going to be 9 times negative 2, which is going to give me negative 18 sitting over y. I didn't say that right. Negative 18y, it's not sitting over y. And in the next multiplication, everything's been canceled out, so I see a negative 2 standing left there. I see here the 9 times 2 times y, so I'm seeing there an 18y. And then 27 times 2 across the top here is 54. So you see how I have cleared out the fractions by multiplying by the LCD. That's a good technique you can always use when you're working with an equation that has a lot of fractions in it. All right, so I need to extend my little red dotted line here. This problem's turning out to be kind of long. My next step is to subtract this 18y from both sides. And I can see that I get a negative 36y. Copy down the minus 2. Here's the equals mark. Those two added up to 0. Copy down the positive 54. All right, so on the next line, I'm going to add 2 to both sides. And that leaves me negative 36y plus 0 equals positive 56. And then remember, we always divide by whatever that coefficient is out in front of the variable when we get down to this last step. So I'm dividing here by negative 36. And I'm going to get positive 1y equals negative 56 over 36. And I know that will at least reduce by a factor of 2. What is that going to be? 28 over 18. Oops, so I can go by another factor of 2 here. That's 14 over 9. So it looks like this works all the way down to negative 14 over 9. All right, so that's a pretty decent way to work that. You could have actually multiplied through by the LCD. Let me show you this. Way up there at the beginning. Well, let me copy it down again and show you one more quick little thing about this that maybe would have been a nice way to start. Depends on your skill level whether or not this is going to be something you can pull off consistently and get it right. It's kind of easy to mess it up. So another way I could have handled this, notice this is times right here. Could have put this whole left side and this whole right side in brackets, and then I could have multiplied by a reciprocal here. And then of course I would have had to balance on the other side, but this works kind of nicely because these are both versions of the same fraction. You've got a positive 2/3 and a negative 2/3. All right, so if you do that, all of that I just highlighted there turns out to be a positive 1 in this case, and turns out to be a negative 1 over here on the right-hand side. So I'm seeing y plus 1/9 equals negative y minus 3. Adding y to both sides. Two y plus 1/9 equals negative 3. Subtracting 1/9 from both sides. That's where I could really use a calculator that does fractions. Let me think about this. Negative 3 over 1 minus 1 over 9. If I convert this into ninths here so that I have a common denominator, looks like negative 28 over 9. And then finally, when I divide by 2, I'll be taking this negative 28 over 9 and dividing it by 2 because that's the coefficient here on the variable. So this becomes negative 28 multiplied by 1 over 2, which becomes not what I got before, negative 14. So let me see what I did wrong. Oh, I copied it down wrong right here. Sorry. It's not 28 over 1. It's 28 over 9. Okay? See if that straightens things out. So that'll be negative 14 over 18. Oh, wait a minute. I'm messing up royally here. That'll be negative 28. See, when you make a mistake, it's always a good idea to go back and start all over again. Negative 28 over 18, and of course negative 28 over 18 reduces down to negative 14 over 9. So maybe that wasn't such a hot way to work it after all. Maybe you should just stick with my method number 1 up there at the top.